Hi, Julian here from PopcornFX. In this video we are going to see how to improve the dust effect we created in the previous videos, how to give a higher apparent density without changing the particle count, how to improve the wrapping node and make it more efficient and simpler. So, first thing, improving the density of the apparent density of the particles. Here we have 25,000 particles and it doesn't look really like there are 25,000 particles. If I quickly switch to wireframe, or if I do a selection rectangle, you can see that there are much more particles, say over there, than what we can actually see. So this is kind of expected because we are fading them out based on the distance to the view to hide the fact that they are in fact in a box and that they are wrapping around the view. But we can do better. In here I was actually using 1 minus the normalized distance to the eye as a fading factor. But this is actually linearly decreasing with distance, so it means that after, let's say for a world radius of 3 meters, after 2 meters they're already barely visible. What we might want to do instead would be to fade them only near the edge and keep them at full intensity till there. So we can quickly play with that by doing a curve sample instead of 1 minus the fader. So here I will create a curve and the sampling cursor will be my fader out of the wrapping node. And now they disappear. That's because my curve is all at 0, and as soon as I bring that back up you will see them appearing again. So here if I just create a point there, you can already see in the viewport that we now see a lot more detail, and that's because we're only fading them at the very edge, near the very edge of the sphere around the camera. So that's as simple as that, just change the way that they are fading. And we still don't see any popping near the edge, and we have the impression of having a much higher density. Next up, we are going to take a look at the wrapping node. So this wrapping node was quite a bit complex. Here we are going from from positions which are in a minus world radius plus world radius cube and converting them to a 0,1 cube and using a floor and subtracting the floor of the position from the position to do the wrapping. So this can seem a bit abstract. So instead I will draw something with my mouse, so it might be a bit jaggy. So let's say this axis is our position. So here it's 1. Oh. Yeah, I don't know why Paint.net is lagging horribly whenever I capture. It's not the Popcorn editor, because when I don't capture it doesn't lag. It's just the capture software that doesn't like it. Okay, this will do. So here, when I have a position along these lines, let's say here, what this does, subtracting the floor, is that the floor of this is actually 1, so it's the nearest lowest integer value next to this value. So the floor of this is this, and subtracting it from the original value gives us this value, which when we plot it in the 0,1 range gives us this here. If I have that value there, the floor is 3, so it gives us this, and it wraps it here. If I have a value there, the floor is -2. Yeah, that's actually -1. So the floor is -2. And this will wrap it back here. So as you can see, as soon as I have a value that's in the 0, 1 range that goes above the upper limit, it will wrap back in the lower side, and if it goes down on the low side, it will go back on the high side. So this is basically the idea of that wrapping behavior. You can see that if I draw it as a function, so you can see that as taking this identity curve where x equals y and applying the floor is actually going to change to produce a graph that looks like this. I apologize for my horrible mouse drawings, but you get the idea. Sorry. And so this is actually also the frac function. So the frac function takes the fractional part of a number. So 2.5 will return 0.5, 2.73 will return 0.73. The trick here lies in that if you take minus 1.2, it won't return 0.2. It will actually return 0.8. There is also the frac sign node in the Popcorn editor that will return minus 0.2. But here we are interested in the frac node. So quickly, the frac sign node will instead give a curve that looks like this in the negative side and like this in the, oh my god, in the positive side. So we can basically replace all this by a simple frac function. So here it works the same, and you will see that this is also much cheaper, which is good. So if I pop the compiler tab with the real-time profiling here, if I use the minus floor, so I have those, it produces those two instructions here, which take roughly, let's say, nine cycles, something like that. If I use the frac instead, now it only takes 3 cycles, so that's always good to take. It's definitely not what's dominating the entire sim, but it's still, still good. And also less nodes, so that's even better. So next thing I'd like to improve is the way that we compute the box around the view. In future videos, when I'll talk about LOD, we might want to change the way this is computed. So currently it's a box between minus spawn radius and plus spawn radius centered around the view origin, but this means that when we compute that wrapping, you have lots of particles behind the camera that you're never seeing. So we might actually want to offset later on that box to be in front of the camera, and having it change its center when we rotate. So we still get the impression we're surrounded by particles, but it's basically faking it. So we can't keep using that. And in here we are basically making a lot of assumptions doing those computations about the way this spawning box is located around the view. So what I'd like to do instead is to create a node that simply outputs the min and max coordinates of that box that we can reuse in the spawn node, in the wrap mode, and this factorizes the logic behind how we construct that box, and we can very easily later on change that logic to have it affect everything that uses that's based on the coordinates of that box. So I'm going to quickly do that here. So instead of doing a round between minus spawn radius and then adding the view position, I want to rand between the min and the max of the box. So the min of the box would basically be a float 3 minus 1. The max would be a float 3 at 1, and both of them multiplied by the radius of the world. Yeah, this is named spawn radius, should actually be world radius. It's actually the name I'm using here, I prefer that. So I will multiply the max as well. So now we have a value between minus world radius and plus world radius. I also need to offset this by the view position. And now these are my min and max world coordinates for the box around the camera, which I can then wire into a rand node to get my final position. Right. So I'm going to create a node out of this so I can reuse it elsewhere. A quick note about the Control G. If you, let's say, if you select these and hit Control G, we will have 2 inputs and 3 outputs. And this is because I have, when I select that, I have 1 wire that goes outside the selection here, which I don't want, and I have 2 wires, even though I'm using a pass-through node here. If I want a single input, I will have to also select this pass-through node. So it can be sometimes a bit confusing. So I won't name that ASD. So let's say it's the view box coordinates. Right. So I can delete that. And now I have a nice node, view box coordinates, that's abstracting how it is computed. And this is box min and box max. Right. A quick tip here: when you create nodes such as this one, the default view is always centered in at the origin of the node graph. But let's say you move your nodes out there. Every time you reopen the graph, the view will reset, and it might not be the view you want. So you can actually save that. So you focus your graph with the zoom you like and the position you like, and then you can hit that little eye icon, and this will basically save the current view, so that every time you reopen your node, the node editor will focus that spot. Anyway, so if I go back into my wraparound camera now, instead of doing all those computations that assume that the box is centered on the view position, that it has side width and depth, height and depth of world radius or twice world radius, we can actually use a single remap node instead. And now that we have those that view box coordinates node, we will just expose the old min, old max, and wire in box min and box max. So this will convert the coordinate that was in the box min, box max range into 0, 1, because the default values of new min and new max are 0 and 1. 0 and 1 here. So by doing this, I can actually bypass all these nodes and directly wire this into the frac. And this doesn't work because I need to set this to evolve. Here my view position was at evolve. And so I need to tell this node to run at evolve as well, because it has a view position which is in auto mode, so by default at spawn. And this is actually what we want, because otherwise at spawn here this will turn this node into evolve if we had set the view position at evolve. So we keep all this to auto, and we say on the node itself when we use it whether we want it at spawn or evolve. So this still works. We can get rid of all that, and it is now a generic way to compute to remap the box coordinates into the 0, 1 range. We need to keep that remap between 0, 1 to -1, 1 because we are using it for the fading distance, but likewise afterwards we can just reuse a remap node and take that and wire the result back. So if I wire it as is, it will disappear. That's because I'm still using the old min old max here. I actually want to remap the box coordinates as the new min and new max, and to say that the old min is -1, because here outside, when I'm taking the value out of this remap, I'm in the -1, 1 range. So I can also delete that. Whoop. And I will actually reuse that node as well. So you can use Alt Shift to create a pass-through node, and it magnetizes the closest wire it finds. Right, so just for things to be clearer, I will add a bunch of additional pass-through nodes that I will just rename with the range of the values. So here it's -world radius. Here it's 0, 1. Here it's still 0, 1. Here it's -1, 1. And here we remapped it back to -world radius, world radius. Right. So some quick tidying up and we're done with that part. That's it for this video. Thanks for watching, and stay tuned for the next video that will show how to implement the pre-warm effect. I didn't actually want to include it in this video because it would just make the video way too long and boring to watch in one go. Thanks for watching.